Hello internet friends, Chris Masto here. I'm finally back with another electronics project. I know I've been messing with my air conditioner lately, but we're kind of going back to one of my favorite topics here, which is to build stuff. And what this one is comes from the Mikey Pipes Discord where I've been hanging out lately, link in the description below. The question came up, does anyone know of a device that will allow you to delay power to a USB port? I'm not aware of any such device, but I thought it might be an interesting one to make. So that's what I've got here on this breadboard. So I'm going to explain how it works and then I'm going to show how it works. Let's take a look at the schematic here. Yes, I'm just holding the camera up to the screen. We're going to have to deal with it. I'm also not very good at drawing schematics, so it is what it is. But let me explain it. The basics here is very simple. It's just an RC circuit going into a comparator, turning on a MOSFET, but I will explain it in more detail and we'll talk about what all the components do. So you can think about it as sort of power coming in on the left here. We've got this LED, current limiting resistor, just to show that it's on. And then this 100 microfarad capacitor charges up through this 1 megohm resistor very, very slowly. So the voltage starts out at 0 and it gradually rises. That goes into this here op amp. I have a dual op amp here. That's in the LM358 chip. The first one is just being used as a buffer. So this doesn't really do anything except essentially copy this voltage from its input here to its output. The reason for that is because we don't want these resistors and things to mess with the charging of this capacitor. So this capacitor gets to charge up on its own high impedance input to the op amp, and then the op amp presents the same exact voltage here on its output, which then goes into the second one. So this is where the meat of the thing happens here. There is a potentiometer here, a variable resistor, which you can use to set a threshold voltage, which is going into the inverting input of the op amp, and then into the non-inverting input of the op amp is coming that voltage from the capacitor charging up. And what this op amp will do is compare these two voltages, and when this one gets to be higher than this one, it'll turn on. Otherwise, it'll be turned off. So you can think of this as sort of setting a threshold. Well, it is setting a threshold, and then this is rising up and up and up, and once that hits that threshold, this output turns on. When this output turns on, it turns on the gate of this MOSFET here, which is otherwise pulled down via this pull-down resistor to stay off. So this turns on and then allows current to flow through this electronic switch. This is our output here, so effectively we've got a device that's not shown here that would be connected to the USB, 5 volts through the device and then into here, and then it can't go through here until this turns on, which is turned on by the op amp, which is turned on by this voltage reaching the threshold value, and that's what implements the delay. A couple other things going on here as long as we're doing completeness. There's an LED here to let us know that it has come on. There is this arrangement, which is feedback in the op amp to implement what's called hysteresis. So what you don't want to have happen, if you imagine this charges very, very slowly, so there might be a point where it's almost at the threshold and just barely crosses over the threshold. And what if that voltage is a little bit wobbly? Maybe there's some noise on the line, whatever. What you don't want to have happen is it's so close that it goes over, under as it's climbing, which causes this to switch on and off rapidly. So we want to have a very solid, clean turn on signal. And what this does is as soon as this op amp hits that point where it turns on for the first time, it will feed some of that voltage back through here and it'll jump right up and cross that region of sort of uncertain instability where it's close to the threshold and be very clearly above the threshold. So that implements a hysteresis via this op amp feedback. And then the other thing we've got going on here is there's a diode to allow this capacitor to discharge. When you turn this thing off, this would take a very, very long time for this capacitor to discharge, and that means that when you turn it back on next time, it might still be on and you won't get the delay you want, so this diode allows that to quickly discharge when the circuit is turned off. And over here we have an input for a bypass button. So let's say that you set this to take a long time to turn on. It's taking a long time to turn on and you're like, to hell with it, I want this to be on now. This would allow you to press a button and that will short out this resistor here, allowing the capacitor to charge up all the way and immediately turn this on. And I think that is all the components here. That's how it works. let's watch it work in practice. It's a little hard to see all the parts on the breadboard because of the wires in the way, but there is our LM358 dual op-amp chip. There is our MOSFET there. There is our potentiometer to set the threshold, our bypass button. Over here is the actual capacitor. It's a capacitor there that charges up. There's the resistor, diode, all the other stuff. Here's the LEDs. So the red one is the on one, and the green one is the timer activated, whatever. And then, of course, we have our USB in and USB out. Here's an oscilloscope that's going to show 2 voltages I have hooked up here. So there will be a green line, which will show the threshold, and then there will be a yellow line, which will show the capacitor charging up to reach the threshold. And I can start this all going if I turn on the power to the USB port. So let's watch it go. And there we go. So green line, again, is our threshold voltage, and the yellow is the capacitor voltage, and you can see it creeping slowly, slowly, slowly up. Then over here, the red LED is on, the green one is not. I'll try to get a good angle here where you can see everything. And so once that yellow line hits the green line, then this should turn on, and you'll see our device that's connected to the USB port will also turn on. Any moment now, and there we go. So this is on now. And you can see the hysteresis here. You can see that jumped up, so that made sure that that yellow has no chance of bumping back down below the green. We didn't change the threshold voltage, we changed the input voltage, but it's effectively the same thing. So that's how it works. And then I can turn this knob here. I'm going to put a nicer knob on the real one, but this allows me to change that threshold voltage. So I can set it higher, and obviously then it'll take longer to come on next time I turn it on. So let's switch it off here, and we'll just demonstrate the bypass button really quickly. All right, so I'm turning it on, and you can see the threshold is a lot higher. So this is going to take quite a while to reach that point, and our device is off. But let's be like, oh, I want to use my iPod. I need this to work now. So you can press this button, and that will, I'm going to back up here so we can see everything. Press this button, and now it's turned on, and you can see that did that by instantly charging the capacitor up all the way, so that it's always going to be above the threshold. And that's how the USB power delay circuit works. So next, I will be turning this schematic into an actual circuit board and building it. I'll do that in a separate video, or perhaps series of videos. If you like this kind of stuff, you like my channel, please do thumbs up and subscribe. Most importantly is subscribe. I really appreciate that, and I'll see you in the next one. Bye.